Welcome to another new video of interesting math problem on our channel Math Solutions for You. Please do like, share, comment, and don't forget to subscribe to our channel. What is the largest side of an obtuse triangle whose sides are consecutive even integers? We start this problem by letting the three sides of the obtuse triangle be 2n minus 2, 2n, and 2n plus 2, which basically represents three consecutive even integers. And here one constraint that we have on n is that it has to be an integer that's greater than 1, because if n is equal to 1, then 2n minus 2 becomes 0, which obviously can't be the side of a triangle. Next, we draw an obtuse triangle, and let's call the sides A, B, and C, with C being the longest side, and that's the side which is opposite to the obtuse angle of the triangle. So if C is the longest side, then we have to assign the largest of these three even numbers to C, which is 2n plus 2. So we assign the value of 2n plus 2 to C, and then we assign the value of 2n to B and 2n minus 2 to A. And the most important question here in this problem is, what is the relationship between the sides A, B, and C of an obtuse triangle? Now we know that there is a famous relationship that governs the sides A, B, and C had this triangle been a right angle triangle. And that relationship is basically the Pythagoras theorem, which states that the sum of the squares of the two shorter sides will be equal to the square of the hypotenuse, which is the longest side in a right triangle. There is actually a relationship which is very, very similar to this for an obtuse triangle. The difference is that instead of an equation, it's an inequality. And that inequality states that the sum of the squares of the two shorter sides of an obtuse triangle should be less than the square of the longest side. So in this case, a square plus b square should be less than c square. So this is an inequality that's special for obtuse triangles. And in addition to this, we'll utilize another inequality, which is not just for obtuse triangles, but for any triangle in general. And that inequality states that for A, B, and C to be the sides of a triangle, the sum of the two shorter sides must exceed the longest side. So in this case, A plus B must be greater than C. So with these two inequalities, we can start to solve the problem. So let's first start with the square. So we basically have a square plus b square less than c square. So a is 2n minus 2, so we have 2n minus 2 whole square. B is 2n, so we have 2n whole square. And then c is 2n plus 2, so we have 2n plus 2 whole square on the right hand side. And then from this we can obtain 2n square, 2n whole square, less than 2n plus 2 whole square minus 2n minus 2 whole square. And on the left-hand side, you have 4n square. And then on the right-hand side, we can take the 2 out of the parenthesis on the right-hand side. But since there's a whole square, so that becomes 4 when we take it out of the parenthesis. So that's why you see the 4 in the terms on the right-hand side of the inequality. So we have 4n square less than 4 multiplied by n plus 1 whole square minus 4 multiplied by n minus 1 whole square. And then if we divide both sides of the inequality by 4, we get this, n square less than n plus 1 whole square minus n minus 1 whole square. And it's pretty trivial to show that the right hand side is simply equal to 4n. If you expand out those whole square terms, you can show that the right hand side of the inequality will be 4n. So we end up with n square being less than equal to 4n. And since n is not 0 and it's a positive integer, so we can divide both sides of the inequality without altering the inequality itself. So if we do that, we basically get n less than 4. Next, we start with the other inequality, which is simply a plus b greater than c. So again, we substitute a is 2n minus 2, b is 2n. So on the left hand side, we have 2n minus 2 plus 2n, and on the right hand side, we have c. So c is simply 2n plus 2. And from this, we can get 2n greater than 4, and basically we have n greater than 2. So if n has to be an integer and it has to at the same time satisfy both of these inequalities, then the only possible value of n is n equal to 3, because it is less than 4 and greater than 2, and the only integer value that satisfies these two inequalities simultaneously is n equal to 3. So once we have n, now it's very simple to find the longest side c. C is simply 2n plus 2, and if we substitute n equal to 3, we get c equal to 8. So the correct option in this case will be option B, 8.